I think David's done a good job at the beginning anyway, so I don't have to repeat certain things. So I can really focus on talking about writing plugins for Gradle. No, I've been asked to make a more basic presentation of that, so we won't go into a lot of the technical things. I would assume not many people have written plugins for Gradle. How many people here have actually done it before? Okay, so maybe a third. Okay, so hopefully we can still teach you something. You can get an idea of this. Okay, right, so I actually live in the UK. I've been around the block a couple of times, I think. I grew up in a time when Make was the only thing you can use for building stuff, pretty much. So I've gone through that. I've worked with a number of different build systems, and NANT, and Make and scones, and I don't know, a bunch of other things. So I really like Gradle because when I come along, I think it's actually a very great way of building stuff. Not just building it, deploying it as well. And I think that's what sets it apart from other kind of build systems at this point. So I even think comparing Maven to like Gradle really compares a very, very little window of what actually Gradle can do. So I've written a couple of plugins for Gradle as well, so hopefully I should have done it, otherwise I shouldn't be at here talking. Doing a variety of very, very strange stuff. I've actually even written one of the plugins to wrap GNU Make, so that we can actually integrate old build systems and have ways of migrating stuff. And there's quite a number of other ones as well. There are a couple of them still up there, so but if you go to GitHub, you can find them. And you have my Twitter ID up there if you want to talk to me afterwards. Just one thing about this presentation, it's actually written in ASCII Doctor, and if you haven't used an ASCII Doctor, then I would suggest that's something you look into. And it's all eventually been put together and built by Gradle. So it does use a couple of other things, but yeah, this is it makes it so simple. If you use Gradle's continuous building mode, you can just keep on editing your presentation. It keeps on building it as well. Okay, so before we carry on, there's this Twitter account called the Daily Gradle, and it sends out one tweet a day with a tip about using Gradle. So if you're interested in that, it doesn't spam or anything else. It normally goes around at about 4 p.m. UTC or somewhere there. Depends how they get scheduled. Okay, so that's just one thing. Or you can actually just search by the hashtag or Gradle tip as well. Okay, so getting onto building plugins themselves, I think one of the problems is there is no consistent way that people have actually written about of how to write plugins. They've actually talked about the technical things, but I mean there's more to that today. And the Gradle DSL is very, very powerful, but we don't want to go and just write the quickest way of getting something to build, because if you can actually put your plugin out there for people, they are going to expect certain things, even if they don't say that. And these are the kind of things they are looking for. They are looking to have a DSL that's readable, something that's really expressive, and also flexibility, which is sometimes what people complain about Maven, and they would say, well, Maven restricts you to do stuff. We know the good parts of Maven, but we know the moment you go out of the comfort zone, it's all pain. So you would like to have the flexibility to do things differently if it needs to do. And obviously you want something to be pretty much consistent. So you get used to the ways that core Gradle is done with plugins and putting up properties and calling methods. And if you write a plugin, you want the same kind of thing as well. You want to give that back to your build script users. So that's quite important. So this is the kind of things I would like to cover in a very, very basic way. If we want to see more complex stuff, there's a whole bunch of slides at the end of this, which we're not going to talk about, but if it goes up to SlideShare, you can actually look into that as well. I've also written a book on the topic, which is on LeanPub, and we'll give you a link at the end. Okay, so the first thing about just starting this plugin is there's a specific layout that you would typically follow, which follows the standard kind of thing how you would normally do a project with Groovy or with Java. Now, you can write your plugin in pretty much any JVM language if you really want, but Groovy and Java is going to be the main two. I know somebody's actually tried to write a plugin in Clojure, so it can be done. But this is the kind of structure you want. So you're going to have your source folder, you're going to have a main underneath it, and then your Groovy folder. Obviously, you're going to have another test folder for the test code. An important thing is that you need that meta inf file in there, which is a little bit of the glue that you need to actually get your plugin loaded. And then you will need a second folder, which you get created if you run Gradle wrapper. So that's quite important. If you write a plugin, use Gradle wrapper to build the plugin so we have consistency in actually repeating the build. And if you haven't used a Gradle wrapper before, then go and read about it because it's on the Gradle documentation. Now, starting your project is pretty much as simple as this. So you will have the first part up there, which is just typically the repositories where you're going to pull things from. So we normally start with JCenter because you can pull stuff from JCenter even if it's on Maven Central. I suggest you write your plugin in Groovy. You can write the whole thing in Java, as we said, but it's just a way quicker to actually write it in Groovy. And then typically you have to put in two dependencies. The one is compile for Groovy itself. So you use local Groovy, so you actually get exactly the same version of Groovy that's used by Gradle. And the other one is Gradle API, so actually the appropriate APIs of Gradle gets put onto the class path when it gets compiled. Then typically you're actually going to test your plugin with SPOCK. Obviously you can do it with something else. Once again, save yourself some pain. Just an important thing is normally when you use SPOCK is actually exclude module Groovy all, so it actually doesn't try to pull down its own version of Groovy. That's just because you're not always necessarily sure when you write a plugin which version of Groovy you're getting underneath the hood. You can check. And there's a little trick you can do with this. So if you actually put something up like this before, you can determine which version of Groovy is running, and then you can actually force it so that it loads the correct version of SPOCK by doing this. Okay. Right. The next thing you have to put on is that you need a plugin class, otherwise your plugin won't get loaded. The standard layout of a plugin is basically that. You need to inherit from, or you need to implement plugin project, and you also then need to implement this apply method. And the apply method takes a project, and then you can do basically anything on it that you need to create tasks, etc. The other thing is that you actually need this properties file. And the important thing about the properties file is that the name of the properties file actually must match the name of your plugin identifier. So if you're used to using Gradle now, you notice you say apply plugin, it's normally a dotted name nowadays, as the Gradle guys want it. So those two names must actually match. So if I'm actually going to write a plugin called Idiomatic Gradle offering, then I have to put that into the file name as well. And then inside, you must actually put the name of your class that will get your plugin class gets loaded. Then the other thing you're typically going to do is, in most cases, you're going to create task classes. Now, there's a variety of ways of doing it, but for most people, it's the standard point is to start from inheriting from default task, which will give you a lot of methods you can actually work with. And you will need to normally at least put task action on one method, because that's the one that actually gets called by Gradle when it actually runs the task. Now, people normally ask about compatibility. So if you want your plugin to work with the biggest range of versions of Gradle, etc., or different to JDK, just a couple of things that you would want to do. Now, Gradle 1.x used to support JDK 5 and better. Now, still with Gradle 2, and apparently with Gradle 3, the minimum supported version is still going to be JDK 6. So if you want to have that kind of range, you'll probably have to make sure that your plugin works with JDK 1.6. The other kind of thing is also, what's the range of Gradle versions you want to support? If you want to be safe, write it for Gradle 2.0. And it will generally work for everything, unless the new model that's now being promoted in Gradle, if you want to really start using that, I would suggest you actually base your baseline of Gradle 2.10. Obviously, you can try push it up, but try to be conservative in the version of Gradle and JDK that you actually use to build Gradle with, your Gradle plugin with, because it will just prevent a lot of issues that you're going to get on GitHub. People complaining about things. Unfortunately, we know now with quite a number of plugins, they are definitely going to move up from 1.6 to 1.7 simply because the libraries we are using underneath are no longer supported in 1.6. Now, the easiest way, and we actually have to give Andre the credit for this because he actually showed me how to do this. Normally, you would just put the target compatibility and the source compatibility as the minimum version of JDK. Unfortunately, this does not work properly. Because somehow, there's definitely a bug in Gradle still, and I don't think they have even fixed in the latest version, is you also need to tell it for your Java compile and your Groovy compile task to actually read that version. So the code that you're actually going to put into your build script for building the plugin is this. Then the other kind of things is that if you're going to support the minimum of Gradle and your Gradle wrapper properties files, make sure the correct version is in there, which will normally get created for you if you run Gradle wrapper. But you might be running Gradle wrapper with a different version of Gradle and forget to specify to it which version it has to use. So remember to go and check this. So that's the basic minimums you actually have to use. Now, before you want to do anything else, this is one of my biggest beefs I have with people sometimes writing plugins, is they forget about this little thing called offline. And I actually write a lot of code sitting on a plane or something like that, where there's no Wi-Fi. And you don't want to build, and then it can't because it's trying to go online to do things. So one of the things you have to put is to try to honor it when you write a plugin, so it actually recognizes that Gradle is being run offline. And this is pretty simple, really, to do, because all you have to do is in your task class, is to tell it to be disabled when it sees offline has been switched on. And the way you do this is by actually getting hold of the Gradle object from your task, and that actually gives you access to the start parameters, which you can actually then interrogate to find out where the offline has been provided. So in this example we had there is the VFS copy task that comes from the VFS plugin. So that allows you to copy things between different servers. But for instance, we don't want a VFS copy task to run if we're offline because it's not going to make sense. So we actually want to have that task to be skipped. So this is a quick way to actually write it into the plugin so that people actually use it later. Who uses, for instance, the VFS plugin doesn't actually get stopped in there and work if they're actually working offline. I think this is really an important little point to remember. Now, there also this kind of things, do you just want to use properties for writing the task properties, or you should use methods? And the recommendation is to use methods because it can give you a lot more flexibility in terms of actually giving a more expressive DSL. I mean, it's quick to do the simple Groovy trick to just give a property in the class, and then Groovy would actually do all the rest for you. But you'll really have to do a little bit of extra work, I think. And we're going to get to that. Because doing this kind of things actually allows you to do something like lazy evaluation, etc. If you want quick evaluation, then it's fine to just use the property. But you can do a lot more with having methods instead of just plain properties. So, a good example of this. Let's say we want to do a collection of files, because that's a common thing we want to do, typically in our Gradle files. Now, we can do this quick trick. We can just say, here's the name of the property, and we actually put an annotation on it, and that's done. The problem is, now we have to put in all of these square brackets and things like that if we want to set it. So for me, that detracts from the readability. The more of these little pieces of syntax you can remove to use the things that Groovy provides you with to have more readable DSLs, is do that. So I don't really want to do what's on the screen now. I rather want it to look like that. So I want to have all of this kind of flexibility in there. For instance, I just want to be able to post one thing into my files, and I want to call it a couple of times, so I don't have to have one big list. It allows me to just append additional files to it. Or I want the ability to, for instance, run a closure so that it really performs lazy evaluation, not at the point where it actually configures, but at the point that it runs and only determines the value then. So by doing things like, by doing it this way, we can actually give it a lot more flexibility. It even gives us the chance to reset values. For instance, a plugin might provide default values and want an easy way to overwrite it. So doing it with methods would actually give us that ability. So how would you actually then do this? You will go back sort of the old way, sort of a little bit more of a Java-like way of doing this. Instead of specifying just a property, make the property private, and notice you actually make it an object, not a file, because now you can put anything in there, and you can actually use things underneath from what Gradle provides you to do the conversion at a point of time when it's required. So let's look at it. The first part is just, well, we skip get documents. Let's look at the second two. So we have set documents, which allows you to reset everything. And as effectively any files were added going to be removed, and just a new set of files would get added. So if you use this kind of thing, then you can do an assignment, which you would expect to happen. Or we put in the third method in there, which will then take a list and it will just keep on appending. So you can do this a couple of times. Great, so we actually achieved it. But now, what do we do with this list of objects? From the objects, we need to get back to files. And we use this little method in the Gradle library, which is just files. And you should probably be familiar with it because this sits on the project. And it does all this kind of stuff for you automatically. So yes, it's not really magic, but it's great. It's just things you don't have to write yourself. So by doing this little couple of things, you already provided your users of your build scripts and your plugin a lot more flexibility, and you added a little bit of extra code. So I think this little trade-off is absolutely worth the while. And generally, that is just the kind of points we want to make. Just make it easy for the people who write scripts. Don't make them fight your plugin. So this is the first point we're going to actually have to do. Is if you think of collection of files, it illustrates this point very, very well. Now, we can do a lot of annotations, and this is the next thing you have to go, and this is you have to read about all of these annotations, because they are the things that tell Gradle when to rebuild or when to run a task and when not. So if you put these kind of things in the right places on your methods, or on your getters or on your properties, then Gradle will know. If you don't, then you're going to get tasks that are not getting rerun, and your users are going to get frustrated about that. As I said, there's a couple of them. I'm not going to cover all of them now. Just go and read, because all of them are actually Gradle docs. We're going to do the same kind of thing. Let's say you have a collection of strings. That's something that gets used a lot as well. And we're going to do this in a similar way to the files. But in this time, we're actually going to use another little method which doesn't really appear directly on if you read the Gradle docs, but it is there. And it's this whole collection util stringize function. And once again, you give it an array, and given an array, it just goes and converts the stuff to strings, whatever it is. So it's so simple. And I mean, even once again, we always stick to this thing is keep things as objects and only convert them to the right type when the task runs. Don't try to do it earlier, because that gives you a lot more flexibility. We can do something similar with maps, because once again, maps are something that you actually see a lot being used in a lot of properties. For instance, the test task. If you configure the test task and you want to pass system properties down, that's actually a map. But you don't want to go to this whole kind of point again there where you want to get rid of those square. Oh, there we go. Finger trouble. You don't want to actually go to having this kind of things, having square brackets. So let's just try and remove it. We just want to write it without that. We also want to have the option of appending things to the map the whole time. So instead of doing it this way, just do it this way. So this is what you want to see. And then if you want to have an explicit reset, just assign it. So this is really nice. I mean, if you run something like the Java exec task, this is something that you actually sometimes have to do. So you want to provide your users with this, of your plugin, with the same kind of functionality. And this is something really simple. Once again, if you can remember things like this, you will already provide your plugin users with a lot more flexibility. And they would probably like you. They'll like your plugin. People don't like your plugin when they have to fight things. The bin tray plugin is an example. It's fine if you use it, till you want to try and publish to 2 repositories within the same build, and you can't, because the way it's been written. So you want to get away from that. You want to have the ability that people can have a default task, for instance, that's there, quick to use, but then you would want to also have the ability for them to instantiate another task. Right, so a couple of minutes. What about compatibility testing? Because this is the one that comes around a lot, and you want to make sure when a new version of Gradle comes out, your plugin works with that. So, or you are writing it, you might be using a certain version of Gradle and you want to make sure it works with all the versions and you want to try things like that. Now, there is more than one way of doing this. Now, in Gradle 2.7, TestKit was added as the first incubating feature of TestKit. Now, by now, it at least has multiple version testing. So TestKit allows you to actually now run your sort of plugins as code, and you can run inside your SPOCK test. And David had an example of that. That's actually I used to illustrate everything. And it still falls short in ease of use, unfortunately. So you can use it and you will get good benefit out of it now. But there is still that kind of thing that is still incubating and is growing. And you might suffer some growing pains with it. But it only works if you build with Gradle 2.7 and later on. What if we actually follow our suggestions and build with Gradle 2? So for that, we have something else. And obviously, I'm going to be biased about it because I wrote this plugin. It's called the Gradle test plugin. And it actually allows you to write Gradle scripts as part of your testing in the way that you would normally write Gradle scripts, and you put them in folders, and you call them build with Gradle, and you put everything else with them. And then you actually carry on from that, before we carry on. So that's all you need to do to pretty much apply it. I use the old way because I am assuming I'm writing my plugin with Gradle 2.0, so I can't use the new fancy plugins closure. And if I apply this, all I have to do is then, under my source folder, create a Gradle test folder. And underneath the Gradle test, I can create one or more folders, which are the names of the tests. And in those folders, I put build with Gradle files. And underneath that, you lay it out as if it's a normal Gradle project. And there's a task that you have to add into a thing called run Gradle test, which just actually evokes it. So when your plugin build runs, it will actually, when it gets to the Gradle test task, will actually look for run Gradle test tasks inside the other build Gradle files and execute them. And that's actually how you can actually run them. And that actually makes it relatively simple. You just tell it which versions you want to test against, and it just goes off. It downloads them automatically if you don't have them. You can configure it to look for Gradle distributions in, for instance, your SDK man folder as well, or in the Gradle list, etc. So it doesn't necessarily have to download it every time. It's up to you how you want to configure it, but it's pretty much all you have to do. And then if it breaks, it will just give you a big message, and it's not most user-friendly in terms of the error you get, but you know it fails against that version of Gradle. There's some things online to do this where we actually want to start putting Gradle test underneath, so we can actually all of the power of Gradle tests, but still give you the ease of writing things as if it's just plain Gradle. Okay, now, if you think this is the basic things that just starting writing a plugin, I think people should actually know. So you know about compatibility testing. If you just take those couple of things on board about honoring offline and doing your files and your strings, etc., in a way that actually provides a lot more expressiveness, then I think a lot of people actually like your plugin and it will become more acceptable as well. So that's the point where I'm going to stop. There is, that's the book I was referring to. It's called Idiomatic Gradle. It's called 25 recipes, but it's actually only 20 in them because I'm still arguing with myself which is the last 5 to add. But it will get finished shortly, and then I'm going to start a second version which concentrates purely on the new model. So you can get it off LeanPub. There is a URL on it, but it's there as well. If you want to take the QR code, take it today and order it, it will be free. So for anybody that's in the conference. So that brings it to a summary. So always keep your DSLs, your extensions as beautiful as possible. And don't spring unsurprising behavior on the user. And if you want to tweet about it, you can tweet about Idiomatic Gradle. Thank you very much.